welcome back to Up in the Air. I'm Meredith Fish.
And I'm JP Nicola. Thank you for joining us on this last show of the semester.
This will also be the final show for JP and I, as well as Ryan Breton, who will be giving us a look at the weather pattern next week and our climate outlook.
At the end of the show, we will have a special goodbye, but first we have a lot to discuss on this week's show, ranging from renewable energy, westerly wind bursts, and the upcoming hurricane season.
Students from the Climate Dynamics class will be by to discuss the connection of certain atmospheric indices to climate change.
Also, Nathan Flinchbaugh will join us to talk about tornado trends in the U.S.
But first, here's Update in the Air.
Another connection to the drought in the West has been made thanks to recent research. Strong easterly trade winds along the equatorial Pacific have not only pushed warm water westward, but also below the surface. This has contributed to a temporary slowdown in land surface warming over the past 15 to 20 years. Due to the ocean and atmosphere being intimately linked, these ocean conditions have helped set up a ridge pattern that deflects storms into Canada. The results of the research show that 92% of the dry conditions in the West can be tied back to the trade wind shift in the Pacific, with the remainder due to humanity's greenhouse gas pollution. This study, along with others, shows the importance of tropical Pacific conditions for U.S. droughts. It also illustrates the need for accurate and long-range prediction of tropical Pacific climate anomalies.
The journal Nature Geoscience recently published a paper examining why predicted El Niño events didn't play out as anticipated. The study found that prolonged wind bursts originating in the western Pacific can have a strong effect on whether an El Niño event will occur and how severe it will be. By analyzing 50 years of tropical Pacific sea surface temperature and westerly wind burst data, they were able to identify 3 distinct varieties of El Niño, and using the westerly wind burst can determine which form will take shape. This paper will help redefine future predictions of these global-scale climate events.
Germany is known for its use of renewable energy such as wind and solar. Their decade-long €120 billion investment to shift towards low-polluting energy forms is proving critics wrong. Critics that claim the variable flows from renewables will destabilize the power grid. When transportation and heating are included, 9% of Germany's energy comes from renewables, triple the US level. Relying on renewables does put added stress on forecasters to deliver accurate and precise forecasts, but researchers in Germany believe the grid has the potential to consist of 50% renewables in the future. A large advance in the implementation of renewables could be the development of reliable batteries to store excess power when the wind isn't blowing or the sun not shining.
A collaborative project between the National Park Service and the University of California, Berkeley, quantified the amount of carbon stored and released through California's forests and wildfires. The results could affect the state's ability to meet the goals mandated by the State Global Warming Solutions Act, as the wildfires and deforestation are contributing more to greenhouse gas emission than originally thought. Although the forests of California act as a huge carbon reservoir, once the vegetation dies or is burned, it releases large amounts of carbon into the atmosphere. With projections of more wildfires in the West, means that they need to account for this source of carbon emissions when trying to meet the state greenhouse gas targets for 2020.
Colorado State University's Department of Atmospheric Sciences has released its early prediction for the 2015 Atlantic Basin hurricane season. 7 named storms with 3 hurricanes, one of which to be a major hurricane, would mean one of the quietest seasons in decades. This is in response to the high likelihood of at least a moderate El Niño event, as well as relatively cool tropical Atlantic water temperatures. Atlantic Basin tropical cyclone activity is forecast to be about 50% below the recent 2005 to 2014 10-year normal, according to tropicalstormrisk.com forecasters. This season's predictions compare to the normals over the 1981 to 2010 period of 12 named storms, 6.5 hurricanes, and 2 major storms. However, a season can deliver many storms but have little impact, or deliver few storms and have one hit the U.S. coast with major impacts.
Researchers at the Polytech University of Catalonia built the first ever software to analyze the entire life of a building from construction to deconstruction. The software allows for different scenarios to be simulated, enabling the effects of global warming on construction projects. Nowadays, many IT solutions are present to calculate energy consumption, but they didn't deal with all the environmental and social consequences, which are fundamental to a sustainable system, according to one of the researchers. The scientists believe this software has other uses, including testing new materials, constructive solutions, or climate analysis systems. As we have seen many times with Up in the Air, the weather and climate industry affect more industries than we think. But that's all we have for this week's Update in the Air. Up in the Air will be back in a moment with more.
Welcome back to Up in the Air. Now we will feature work done in the Climate Dynamics class here at Penn State.
Ann Baylog, Matthew Strausser, and Zach Ellis will now discuss our understanding of the Arctic and North Atlantic oscillations and how they relate to climate change.
The United States has experienced two extremes on opposing coasts in recent years. While the West Coast has been in a state of record drought, the East Coast has been in a state of record cold. While there are many factors that control the prevailing climate of a location, a measure called the Arctic Oscillation and its fluctuations can in part help to explain these two extremes in the U.S. The Arctic Oscillation is a climate pattern characterized by winds circulating counterclockwise around the Arctic at around 55 degrees north latitude. The Arctic Oscillation consists of two distinct phases, a negative and a positive phase.
In the positive phase of the AO, pressure in the Arctic is relatively low compared to the pressure in the mid-latitudes. This pressure gradient keeps the jet stream farther north, which allows storms to travel farther north. This causes higher precipitation amounts in places like Alaska, Scotland, and Scandinavia. Additionally, the western U.S. and Mediterranean have drier conditions, and the eastern U.S. experiences warmer temperatures. In the negative phase of the AO, pressures in the Arctic are relatively greater than those over the mid-latitudes. This causes kinks or dips in the jet stream, bringing cold air farther south. In a typical negative AO phase, mid-latitudes experience colder temperatures and increased storm activity.
Since the mid-1990s, a trend in more frequent negative AOs has been observed. This is a phenomenon that has large-scale implications for the U.S. climate, as evidenced by the effects of negative Arctic oscillations. While this trend in negative AOs is not fully understood by scientists, research in the areas of sea ice loss, the influence of snow cover, and natural decade variability are being conducted in the attempt to explain the phenomenon. Interestingly, though, while the past 2 years have been more so in the positive phase of the AO, helping to explain the extreme drought in the western U.S., the eastern U.S. has experienced record cold and snowfall amounts which go against the basic understanding of a positive AO. While the majority of the northern hemisphere's mid-latitudes enjoyed warmer than usual winters, the extreme deviation in the eastern U.S. was caused by an eddy in the polar vortex. Essentially, a portion of the Arctic Oscillation behaved as though it were in a negative phase. This eddy brought cold Arctic air from the north, causing the eastern U.S. to have a climate more consistent with that of a negative phase AO.
It is worth noting that another oscillation known as the North Atlantic Oscillation is closely related to the Arctic Oscillation in that it describes the varying pressure gradients in the northern latitudes and the resultant effects on temperature and storm tracks across the continent. The NAO is another valuable measure to take into account to help explain the current extremes on the U.S. coast. The negative NAO that we are currently experiencing is consistent with the bitter cold on the East Coast.
Paying attention to the Arctic Oscillation can give an indication of what the coming weather may look like. Positive phase AOs bring warmer, more moderate weather to the East Coast, while negative phase AOs tend to bring cold and stormy conditions. As our understanding of the driving factors behind the fluctuations in the Arctic Oscillation increase, so will our understanding of climate change. For Up in the Air, I'm Ann Baylog.
And I'm Matthew Strausser.
And I'm Zach Ellis.
Welcome back to Up in the Air. It has been seasonally warm during much of April here in State College.
It sure has. A nice change from the cold and snowy weather we've had.
It's now time for this week's Climate Outlook. Here's Ryan Breton to tell us if that warm trend will continue.
Thanks very much, Meredith and JP. That's right, the weather last weekend was just beautiful for blue-white. Not the case this time around, much cooler, and that cooler weather is a theme as we head into our 8 to 14-day outlook. There really are no major changes in our overall weather pattern. We'll start with a look at the drought monitor. A lot of the state really could use some rain. We're running abnormally dry from the eastern part of the Laurel Highlands through the central mountains and all the way through the Poconos and into northeastern parts of Pennsylvania. So any sort of rain that we get is beneficial, even though it's not an extreme drought at this time. It's something that we're going to continue to monitor, and a lot of folks up and down the eastern seaboard are dealing with at least abnormally dry conditions. But as we've been talking about for months here and up in the air, it is the central and western part of the nation where we really could use some rain. The darkest red is an extreme or exceptional drought, and that's what we're seeing through parts of Texas, Oklahoma, and of course through parts of Nevada and much of California, where we've talked about the restrictions that have been put in place on water usage as a result of the drought that's ongoing there. In terms of our 8 to 14-day outlook, this is for the period from April 29th through May 5th. So when we talk about averages here in State College, the average is in between about 64 and 68 throughout this period. And you can see that we are expecting below normal temperatures. So temperatures likely below that, meaning 50s. So not terrible. There certainly could be some days a bit lower than that. But when we talk about below normal this time of year, it's a bit better and a bit more manageable than below normal in even February or late March. Out through the west, this is where temperatures will remain above normal. Same story, same weather pattern that we've dealt with for several months here across the continuous United States. Precipitation outlook below normal through a lot of this part of the nation, but the Gulf Coast, or maybe some Gulf moisture getting involved, so maybe above normal down through Florida and parts of Texas as well, and then below normal through areas just north of the Four Corners here in the western part of the nation. So that is the climate outlook for this week, and that's my final time bringing you the climate outlook here on Up in the Air. It's been a great time being with you each week through the semester the past 2 years. It's been a great opportunity for me. I'm certainly going to miss being a part of the show, and we're going to miss Meredith and JP, and we do miss Dakota, who was with us as well in the past. I'll still be here. You may see me on occasion, but I wish Meredith and JP well as they head on to the next chapter. In the meantime, back to you, Meredith and JP.
Thanks, Ryan. It has been wonderful working with you these past 2 years. Up in the Air is sure going to miss you, as we've had a lot of fun over the years. JP, unfortunately, this is your last episode as well.
That's right, Meredith. It's been a great year working with the Up in the Air team. I sure learned a lot from this experience. Graduation is coming quickly, and I'm hoping to enter the weather-rich job market this fall.
I sure will miss our weekly meetings and hanging around the TV studio with you, but I wish you the best in your future.
Thanks. Now, Meredith, you're also graduating. What are your plans for this fall?
I'll be attending Scripps Institute of Oceanography in the fall to pursue a PhD in climate science. I'll be working with an oceanographer and atmospheric scientist to study Western weather, specifically atmospheric rivers in California.
Wow, that sounds really exciting. Maybe future episodes will feature your research.
Well, that's the goal. But I have thoroughly enjoyed the past 2 years on Up in the Air and will never forget this experience and Paul Knight for making this all possible.
We wish you luck in the future.
Thank you. Unfortunately, that's all we have for this week's episode and another season of Up in the Air.
Tune back next fall for more work done in the field of meteorology by Penn State students.
On behalf of JP, Ryan, and myself, it has been a pleasure giving you updates on the weather and climate enterprise each week. See you next time, Up in the Air.